क्या बच्चों दी
मैं बोल तो रहा हूँ।
आप बता दो जगह फिर
गार्डन हिल। ये शाम को जाना है, इवनिंग लिख लो।
तो 11 बजे तो निकलना ही पड़ेगा।
विनीस की
मैं बियर अभी
These are the different locations that each of our ingredients were produced in. As for these are the calculations. So we used the blender for 1 minute and the oven for 30 minutes. Our appliance had a power rating of 2,500 watts and 600 watts. Our power was 2.5 kilowatts and 0.6 kilowatts. And our time was 0.5 hours and 0.0167 hours. Doing the step-by-step calculation, we calculated that the oven usage would have been 1.25 kilowatt hour, and the blender usage would have been 0.01 kilowatt hour, which made a total of 1.26 kilowatt hours. As for the waste we produced, this included the peels of the parsnips and the potatoes, which I later baked into a snack as potato chips. And the plastic that came in the parsnips, we decided to recycle in the recycling section of our university.
After making our sustainable fish and chips, we will now look at the waste management overview. This is our baseline waste audit distribution that we built. So how did we construct this distribution? So firstly, we estimated the baseline values before the waste reduction. So we approximated the values for a single batch. So for each waste streams, we estimate the values, and then we calculated the total waste, and then we calculated the share in percentage. So in the end, we obtained this baseline waste audit distribution. So we can see that the largest share of the total waste comes from the wash water used during ingredient cleaning, preparation, and equipment rinsing. So this is typical for kitchen operations where hygiene and cleaning are intensive, especially with fish and starchy vegetables like potatoes. The second largest share is the organic scraps. This kind of waste has a lot of potential for upcycling, which we will talk about this later. So this will be like turning peels into crisps or composting trimmings, and this aligns perfectly with circular kitchen principles where food waste becomes an input for new value-added products. Packaging material has also a moderate distribution but non-negligible contribution. So likely from the ingredient packaging, such as fish wrapping, pea bags, egg cartons. Plate waste is relatively low, suggesting that we have good portion control and menu acceptance. Oil has minimal contribution, so this reflects the oven-baked preparation method that we used, as this is a sustainable improvement over deep frying method. So this is the first evaluation acts as a benchmark for evaluating further waste reduction progress. This is the waste stream mapping that we constructed. So the targets are set based on reasonable evidence-based reductions. After implementing the sustainability strategies, we set up these targets. So we have the baseline for each streams and the target. So we calculated the reduction for each streams, and we also written down the primary strategy for each streams as well. So this is a summary table for the waste stream mapping. Now we're going to calculate the carbon and water footprint. We're going to separate this into 4 parts: the ingredients, the cooking part, the waste part, and the overall footprint. So let's start with the ingredients footprint. First, we will look at the carbon footprint for this dish. Firstly, we listed down the ingredients for the single batch. So this will be 4 portions for a single batch. And then we went researching for the carbon footprint for each ingredient from reliable sources. And then we calculated the carbon footprint for each ingredient by multiplying the mass and the carbon emission factor together. And in the end, we sum up the total batch carbon footprint to be 2.64 kilograms of carbon emitted for the whole batch. We divided that by 4 to find the footprint per portion, and we found that to be 0.659 kilograms carbon emitted per portion. Next, we do a similar calculation with the water footprint as well. So we listed the ingredients down, which is the same as the carbon footprint, and we also went researching for the water footprint emission factor for each ingredient. And similarly, we compute each ingredient footprint by multiplying mass and the water footprint emission factor for each one. In the end, we found the total batch water footprint to be about 2,261 liters for the whole batch, and per portion would be 565.35 liters per portion. Here is the summary table of the footprint that we summarized. For the carbon emission, we can see that the batch waste production footprint is around 2.64 kilograms of carbon emission, or about 0.66 kilograms per portion. So most of the carbon emission comes from the pollock, potatoes, eggs. For the water footprint, the batch uses around 2,261 liters of water, or 565 liters per portion. So the largest water contribution here are peas, potatoes, eggs, and rapeseed oil. But the rapeseed oil has a high water footprint per kilograms, even though only a small mass is used. Now we're going to look at the cooking footprint. Earlier, we found that the total batch energy is about 1.26 kilowatts hour, so we multiply that with the emission factor of 0.233 to get 0.23 kilograms carbon emission for the cooking process. For the water footprint, we use water for washing, cleaning, and hand washing during cooking. So according to our waste audit, we use about 3 liters of wash water. So we can conclude that the cooking water footprint would be about 3 liters. Now we're going to look at the waste footprint. For the carbon footprint, we will calculate the carbon footprint for each waste stream. So the first one, we have the organic scraps to have 0.0882 kilograms of carbon emission. For the packaging, we find the emission factor and the general waste to landfill and then calculate the carbon emission to be 0.038 kilograms. And for the plate waste, we have 0.0252 kilograms. For the waste oil, if we decide to collect all of it and not dispose it, our carbon impact would be 0. For the wastewater, we have 3 liters of wastewater, so we will get 0.0021 kilograms. Now we have the total waste carbon footprint to be 0.15 kilograms of emission. Last but not least, we will calculate the overall footprint. We will recall the values we found for the ingredients footprint and then sum up with the cooking and the waste. So in the end, we get the overall carbon to be 3.079. and water footprint to be 2265.7 liters in total. Therefore, we can conclude that the total environmental footprint of the oven-baked fish and chips dish would be 3.079 kilograms of carbon emission and 2,265.7 liters of water per batch. So most emissions come from the ingredients, and with cooking energy and waste processing contributing smaller portions. Similarly, the water footprint is dominated by the ingredient production, while cooking and waste activities account for less than 0.2% of total water use. So overall, the dish demonstrates comparatively minimal operating impacts, with the majority of the environmental effects occurring upstream during the production and processing of the ingredients. That is the end of our sustainable dish presentation. Thank you so much for watching our video.